and this is the second video representation of my last year's project that is named by Smart Water Management System. Now earlier we saw the working of the water meter. Now this time we will see the working of the pump, overhead tank and underground tank. Now this is a simple system as used everywhere, as if there is a shortage of water in the overhead tank, then the level sensor will measure the level of water in the overhead tank and it will send a message to the microcontroller or to the system, and basically the system will turn on the pump if in the condition that the underground tank also has some sufficient amount of water in it, then the pump will start and it will fill the overhead tank. Once the overhead tank is full, the pump will stop. So let's see the working here in this case. Now obviously here there is no tank, as you can see, no tank, nor there is a pump. Instead of a tank, I have created an alternative way of representing it. The bulb that you see here, consider it as a pump which will turn on and turn off. And this is the overhead level sensor, basically the ultrasonic sensor. This is the underground ultrasonic sensor. And the two books that you see here it is the bottom of the overhead tank. In this book, consider it, the red one, consider it as the bottom of the underground tank. Now the hardware that we have is basically there in the college, so this is the alternative way of representing the system. I shall reiterate, this sensor, this ultrasonic sensor is the overhead sensor, and this ultrasonic sensor, this one, is the underground ultrasonic sensor. And here is the LCD display. Now right now there is no water here, no water here. So the LCD display shows that the overhead sensor level OH reads 0 centimeter and level UG reads 0 centimeter also, and the status of pump is off. The reason why pump is off is because though there is no water in the overhead tank, but there is also no water in the underground tank. So to prevent dry run or the pump failure or the burnout of the pump should not turn on. Now let me artificially create a level in the underground tank. So I will place an object like this, and now you see the pump has started to turn on. Yes, it has started. Now you can see that the overhead tank still reads level 0 and the underground tank reads level 11 centimeter, which means that the underground tank, the level of water in the underground tank is 11 or 12 centimeters basically. Now let me artificially increase the level of the overhead tank. Now if we see, then the level in the overhead tank is 10 centimeters. Now assuming that the level of water in the underground tank is not reducing, I'll increase the level of the overhead tank. So the level of water in the overhead tank is 15 centimeters. So it has risen from 0 centimeters to 15 centimeters. Now if we know that if the level of water in the overhead tank increases, it should not increase beyond a point. So the pump, that is the bulb basically here, should turn off. So the programming of the microcontroller has been done in such a way that if the level of overhead tank increases beyond 20 centimeters, then the bulb, that is our pump, should turn off to prevent overflow. So the level of water in the overhead tank is gradually increasing. Right now it is 18 centimeters. By the way, the total height of the overhead tank is 24 centimeters and the total height of the underground tank is 25 centimeters. Now you see that the level of overhead tank is 21 centimeters, which has made the pump turn off. So now let us take another case. So again, I have artificially created a level in both the overhead tank and the underground tank respectively. Now, so yes, okay. Right now the pump is on. It is because there is some level of water in the underground tank, that is basically 13 centimeters, and the overhead tank also reaches a level of water at 15 centimeters. Now assuming that when the pump is on, the level of water in the overhead tank will gradually increase and the reading will also increase, the level of water in the underground tank will gradually decrease. So if the level of water in the underground tank goes below a certain level, then to prevent the dry run of the pump or its burnout, the microcontroller should automatically turn off the pump. So let's demonstrate it practically. So the level of water in the underground tank is reducing just because the level of water in the overhead tank is increasing. Now when I remove this object, we shall consider that yes, the level of water in the underground tank has reduced beyond a certain level. So the microcontroller has automatically turned off the pump. Now let's take the third case, that there is some water in the overhead tank. Level OH is 19 centimeters, but the level of water in the underground tank is 0. UG is 0. Okay. Now what I'll do is I'll artificially remove the water in the overhead tank. Now if we see, then the pump does not turn on. Again, there should not be the dry run of the pump or its burnout. So the microcontroller, that is Arduino as in this case, will not turn on the pump. So now let's focus on the programming part. Let's see how it has been carried out. It has been done in a very simple way. The total height of the overhead tank is 24 centimeters and the total height of the underground tank is 25 centimeters. Now the term level OH, as we saw, determines the level of water in the overhead tank, and the level UG term determines the total height of the water in the underground tank. Now the ultrasonic sensor, that is our level sensor in both the tanks, measures the difference in distance between the level of water and its own position. So to calculate the level of water in each tank, we have to subtract the distance measured by the ultrasonic sensor between its position and the level of water and subtract it from the total height of the tank. Second thing, now these are two conditional loops. The first if loop tells us that when the level of water in the overhead tank falls below 5 centimeters, provided that the level of water in the underground tank is more than 5 centimeters, then the pump should turn on, given by the Arduino command digital write pump high. In the next case, if the level of water in the overhead tank increases beyond a level, that is 20 centimeters, because the total height of the overhead tank is 24 centimeters, so we do not want an overflow in the tank. Or if the level of water in the underground tank falls below 5 centimeters, then the pump should remain low. That is, the pump should not turn on. The rest of the programming part